Hey everybody, this is James Tierney with TierneyEducation.com, going through how to solve for the market quantity and price in a Cournot Duopoly. But before we get to that, let's talk a little bit about this concept of a Cournot Duopoly. Well, first, the duopoly part, right? That means that there's going to be two firms. And so we talk about two firms in the market. That means my market quantity, which is always my big or my capital Q, is going to equal lowercase q1 plus lowercase q2. So a duopoly, two firms, we know that the quantity, market quantity, the capital Q, lowercase q's added up are going to be like that. That's the duopoly part. Now the Cournot part, this is telling us that it is a simultaneous choice, meaning they are choosing the quantity. They're going to choose their quantity, Q1 and Q2, at the same time. And what that is basically telling us is the way to solve this, to solve this, we need to use both what we call best response functions. And we're going to work on that when we do the question out over here on the left that I have. So Cournot, what you need to remember about Cournot, two firms if it's a duopoly, and it's a simultaneous choice. So we're going to be using their best response functions. So let's go ahead and do this example, and I'll kind of keep referring back to what we mean by best response function, simultaneous choice, etc. here. So if you're given the market demand of 40 minus 2Q and a marginal cost of 4, how are we going to go ahead and figure out what Q1 should be and what Q2 should be? The first step is that if I know quantity equals, firms 1 quantity, firms 2 quantity, I can rewrite this market demand as P equals 40 minus 2 Q1 minus 2 Q2. And that's going to be important because at the end of the day, I'm going to actually put this up here so that way we have it forever. We know that marginal revenue equals marginal cost is really important, right? That's how we're going to maximize those profits, that's how we're going to make that choice. So we're going to need a marginal revenue. Well, in order to get a marginal revenue, I need the total revenue for firm 1, which I know is, the demand times the quantity of firm 1. So that means my total revenue is going to be 40 Q1 minus 2 Q1 squared minus 2 Q1 Q2, because I'm just taking this price and multiplying each one of these, or the entire thing, by Q1. So notice there's a Q1 here, second Q1 here, there's Q1 there. And my marginal revenue now for firm 1 is we're just going to take the first derivative of the total revenue with respect to Q1. And now some classes, like the intermediate level classes at Penn State, they don't require calculus. So you'll just always either be given the marginal revenue, or you can remember that when we have this linear demand curve, you're just going to be doubling the slope on the Q that you're caring about. So as we'll notice, this will just tell us that my marginal revenue for firm 1, that's why I'm denoting it with a little 1 here, is going to be 40 minus 4 Q1 minus 2 Q2. And again, how do we find that optimal quantity? Right? Marginal revenue equals marginal cost. So I'm just going to take that and set that equal to 4, because remember my marginal cost is 4. So this right here, this line is showing marginal revenue equal to marginal cost. And now what my step is going to be, it's going to be to take that, and I'll actually use a different color here as well. I want to solve for Q1. This will be the best response. This will be the BR1 function, the best response function. So let's go ahead and do this. I'm going to say, all right, this is going to be 4Q1, right? If I were to take this 4Q, put it over there. And then I'm going to take the 4 back, so it's going to be 36 if I subtract 4 from both sides, minus 2Q2. And if I divide everything by 4, divide everything by 4, just going to make this a little smaller and drag it up so we have it. Those are going to cancel. I'm going to get Q1, I'm going to put a star now, is going to equal 9 minus 1/2 Q2. If your algebra is a little shaky, pause the video and go back and make sure you can get to this best response function. Now I want to take a quick break from doing the algebra and talk about what this actually means. This means whatever Q2 decides to produce, this is the quantity that Q1 is going to produce. So if Q2 decided to produce 18, well, that would be 9 minus 9, it'd be 0. There'd be no room for Q1 to be in the market anymore. If Q2 were to produce 0, then we know that Q1 would produce 9. And in fact, if you were to go in and you were to look at, okay, what would be the perfectly competitive amount and what would be the monopoly amount, you would actually see it would be that 18 and that 9. Now, because this is a symmetric game, what we mean by that is both players, or in this case firms, are facing the exact same things, then we know that Q2 star is just going to equal 9 minus 1/2 Q1. So those would be our best response functions. Remember over here when we started, simultaneous choice to solve, we're going to use both response functions. But then what do we do? Well, now we're going to take these and we're going to combine the best response functions. That's your next step, is you're going to combine these two functions by plugging Q2 into my first Q1 best response function. Let's go ahead and do that. I'm just going to move this over to the left a little bit, give us some space. So like I said, we're just going to take this Q2 on the right, put it into the Q1. So we got Q1 star equals 9 minus 1/2. Plugging in that Q2, we get 9 minus 1/2 Q1 star. We put the stars on there because we are optimizing now. This is our best response. Let's go ahead and do some distribution. Q1 star equals 9 minus 9 over 2 plus, remember to distribute that negative sign, plus 1/4 Q1 star. Now, I don't like working with all these fractions, and so the trick I always use is find the largest denominator, just multiply everything by that number to get rid of it. So I'm going to multiply everything by 4. Let's scroll this up just slightly so we make sure we have some room. So this would be 4 Q1 star over here on the left, right? So we're multiplying that by 4 equals, well, 4 times 9 is 36 minus 18 plus Q1 star. And that's just distributing this 4 right here into every single term. Now, again, if your algebra is a little shaky, pause the video, make sure you can get back to this type of stuff. Simplifying this by subtracting the Q1 from both sides, we're going to get 3 Q1 star equals 36 minus 18 is 18. And then if I divide both sides by 3, I'm going to get Q1 star is going to equal 6. Again, this is a simultaneous game, so I know Q2 star is then going to equal 6. And thus, big Q market quantity is going to equal 12. So remember, we started this saying we wanted to find the quantity. Well, I guess I'm running out of a little room, but we're just going to kind of put an arrow, say, hey, we'll do it up here. Now we want to find the price. Well, we know the market demand from the very beginning, which you can kind of still see here on the screen, is 40 minus 2Q, is 40 minus 2Q. But if Q is equal to 12 down here, 40 minus 2 times 12, P is equal to 40 minus 24, so P is going to equal 16. So there you have it. For the Cournot Duopoly, we solved out quantity, plugged it back into our demand, so we got our price. So we know the market price and quantity for this Cournot Duopoly. Whoops. Now I'm going to put everything on the same screen so we can talk a little bit about it to wrap up. Duopoly is two firms, so little q1 plus little q2. So we know we're going to split this up into two firms. We need to get the best response functions and then combine. We get the best response functions by marginal revenue equals marginal cost. So we need the marginal revenue for firm 1 is equal to the marginal cost of firm 1. And then we solve out for Q1, and that's going to be our Q1 star, which is the best response because we are responding to however Q2 reacts. Now, we know that this is a symmetric game, so Q2 is going to be the exact same thing. And we're just using algebra to plug this Q2 into this Q2. Solving it out, we'll get Q1 star equals 6. It's a symmetric game, so I know it's Q2 star equals 6, but you could check your work. Plug this Q1 star back into Q2's best response function. We would get 9 minus half of 6, 9 minus 3. Well, 9 minus 3 is 6. We add those up to get our market quantity, plug it into our demand to get our market price. So there you have it. A brief overview of solving the market quantity and price for a Cournot duopoly. Again, my name is James Tierney. I own TierneyEducation.com. We're located in State College, Pennsylvania, where Penn State is located. If you have any questions, you can feel free to send them in. Make sure you subscribe, send this to your friends who might be struggling with microeconomics. We'll talk to you soon.